So we're going to demonstrate the software installation and do a quick check on the UCTD probe and then go through some charging procedures and general assembly and maintenance. So take the probe out first. You can see it gets shipped with protective covers, so the first thing we do is we take those off.
Because one good thing to remember is there may be another layer underneath that top layer in the case.
Yeah, so typically
don't forget,
there is something
there may be
else
something
underneath.
else underneath there.
So just check for that. The other thing in here is the Bluetooth adapter and the software for the actual probe communication. And now we're going to install the Bluetooth adapter first. This is the Bluetooth adapter here. So the first thing you have to do is install the driver for the Bluetooth. We're going to install the Bluetooth utility and drivers. So at this point, you have the driver software installed for the Bluetooth adapter, and now you can actually install the adapter itself. Do not reverse these steps. Okay. So now we're going to be actually installing the UCTD software that allows us to communicate with the probe. That software is in the little Ocean Science CD. There's a directory called UCTD term version 1.1. We're just going to copy that over to whatever directory you prefer. I'm just going to put it on the desktop. There's some other files on there that are useful. The operating notes and commands, software to process the data from Seabird, some user guides that explain how to calculate sound speed profiles, the user guide that tells you how to use the system as a whole, and a demonstration video that you can refer to kind of learn a little bit more about the system and how it's used in the field. There's also a directory that has a number behind it, and that's the serial number for the probe, and that contains all the calibration files and test reports from Seabird for that probe. So if we open that, you can see there's the pressure test, the configuration, and the calibration documentation for conductivity, pressure, and temperature.
So that probe serial number is 81 and it'll be marked on the probe somewhere.
Yes. You can see right here, not sure if you can see that, that's probe assembly 0081.
Okay.
That matches the calibration information. So now that we've installed the main software to communicate with the probe, that's called UCTD term, always make sure that the library is in the same directory as the application. So the first thing we now have to do is we have to pair the probe with the Bluetooth adapter. So we're clicking on the Bluetooth icon that we just installed. It's going to show the Bluetooth devices. And this is going to scan for available devices in the area when you click on this yellow button. In order to activate the Bluetooth on the probe, you actually have to cycle the plug.
Hold on a second. There you go.
You have to cycle the plug, pulling it out and reinserting it. After reinserting the plug, Bluetooth is active for 2 minutes on the probe.
It's good to remember that and not forget that after 2 minutes the Bluetooth is going to get turned off.
So now the Bluetooth is looking around for devices. And here is the Seabird probe listed as SPE 070200081. And now we're going to pair this probe with the Bluetooth adapter.
I just right click and pair.
Yes, and the passkey you enter is default, DEFAULT, return. And when it's paired, a little chain appears here to see that the two are now locked together. So at this point, we want to connect to the Bluetooth serial port. We have to figure out what virtual COM port is used by the Bluetooth software to talk to the probe. And the easiest way to do that is to say connect to Bluetooth serial port, and then it'll tell you which serial port will be the one that you need to configure the Seabird software to. In this case it was COM10. So we're going to go up here, we're going to start the software, and now we configure the software for communication. COM port was 10, and I'm going to choose a faster baud rate to speed up the communication. I'm also going to connect it right here. There we are, and now we're actually connected to the probe. Okay, so now we're just going to check on the status of the probe. You use the ds command for that. ds, display status, and that gives you some vital information about the probe's condition. First, the serial number up here, then in the line underneath it gives you the date and the time of the real-time clock on the probe, which is important for synchronization with the GPS location. Also gives you information about the battery voltage. This one is 3.76, so this is a well-charged probe. The number of samples that are currently stored on the probe, also the number of profiles stored on the probe, currently how long the probe will record when the data acquisition is activated, how much free memory is on the probe, and that's pretty much the main information. So in order to find out what data is stored on the probe, we issue the get header command, gh, that lists the number of profiles. In this case it's only 2. That's typically the situation when you get a brand new probe. And there's basically it shows you cast 1, recorded on August 3rd, and the time, the number of samples in that profile, the battery voltage when it was recorded, and in this case it also tells you why the recording stopped. It's because I cycled the magnetic plug rather than let the probe continue to record for a full 100 seconds. So in order to get the data off the probe, we use the upload command. Just press upload, and you enter the cast number. In this case I'm just going to choose 1. Say OK. I'm going to give the file a name. There's no need to give an extension. It's automatically will be added. You say save. Since that file exists already, it's going to ask you if you really want to replace it. In this case, I do. Now it's going to download the data. And that data download is complete. You can see that because it's active again. A few other things you want to check is if you want to change the acquisition period, you equal the command, you issue the command set stop seconds, and now you can change it to 200 seconds, for instance. And if you look at the status, it's reflected in the fact that stop seconds are now 200, so whenever you pull the magnetic plug, it's now going to record for 200 seconds. Doing set stop seconds equals 0 will cause the probe to go into continuous acquisition mode, meaning from the moment you pull the plug until you put the plug back in, data will be recorded. But that's a situation you will probably use if you just do very shallow casts and want continuous data from the probe. Just set it back to 100 again. Now, if we want to synchronize the probe clock with the GPS clock, the thing you have to do is you have to set the clock on the probe to whatever time zone you use. In this case, typically it's Greenwich Mean Time, to synchronize it with the GPS. The way you do it is date time equals, and since I can never remember the syntax of that command, I just press 1, 2, 3, and it's going to complain that I entered the wrong format. But now it actually gives you information about what the correct format should be. So let's say we do date time equals first the month 08, the day 03, the year 2011. And I'm just going to choose the local time from the computer right now, which would be 161355, and press return. And if you do a DS command now, it tells you that it has set the date to this time.